Assalamu alaikum. Hello.
Yes, Walaikum Salam, brother. How are you? Long
Alhamdulillah, I'm
time.
fine. How about you? Okay, so I hope you also practice our previous 7 days online training program. Okay, and also try to submit all of assignment.
Yes,
Okay.
yes. Still, I'm doing. Still, I'm. Yeah. Yes. I'm working on. I'm just going through the sessions again. So probably in 2 weeks, I'll try to submit the assignments and then I'll send you all the. If any doubt in assignment, I mean, if I'm not able to understand what I have to do, I'll just ping you in that time.
Okay, no problem. You try.
So I have just one, I have just one request. Like I read somewhere in the articles that using Google Earth image, we can make from 10 meter to 2.5. There is some, I don't know, but I thought you are expert, so you might have done this approach. So I just want to have that one part. I just wanted to know. So later I can do the NDVI, land use, land cover on that 2.5 itself. I don't want to go that 10 meter.
Okay,
I just want
I'll
to
try
do
to
it
show this
on
process
to
also
top
inshallah
of
further
2.5.
next class.
All the analysis
How to make 10 meter to
with
2.5
this
meter.
2.5 itself.
I'll also discuss. No
Is
problem.
it possible?
It's also possible. So 2.5. I think we can
Your voice is.
increase the resolution. We can increase the resolution. Okay, we increase the resolution. It's also possible.
Yeah.
Problem.
Yes.
We try
Yeah,
to
but there is no damage. But there is no damage to the imagery, right? I mean pixels and all those stuff will be the same in high resolution. There is no discrepancy or damage in the
yes.
information of the image.
No. There is no damage of the information of the image. So just apply some
Yes.
technique, advanced technique, and it simply increase the resolution. Okay? Increase the resolution of your satellite imagery.
Okay.
So no problem. Let's discuss
And
all
also
of
we can export it.
things.
Yeah, and also we can export it to TIFF, right? The 2.5 meter.
We discuss all of those, no problem. So I will just make the material for this class, and then I will take the one class. I will try to show you the Sentinel and also Landsat. Okay, both of imagery, how to work. I also discuss, no problem. Okay.
Thank you. But your internet is, I think, there's breakage in your internet, your face. I mean, pixel wise, I can see your face, and there's hang in the image.
We discuss more details. Okay, so now let's
check your internet connection.
Jump over to the session. Okay, just let me share my screen.
Yes.
So previous, I think I take the 2 class for previous. You also try to get all of materials.
Yes.
Okay. And also practice.
Yes.
So basically today discuss about that deep learning. Actually, deep learning is a very vast topic. Okay, a lot of concept, lot of theory, lot of things we need to discuss for the deep learning. So I hope you can also catch all of those. I try to show you that all of things from beginners
Voice
to
is
advanced.
breaking. Voice is breaking.
Okay, just a minute.
Voice is breaking. I cannot hear.
Can you see my screen now?
Not clearly. It's hanging and sometimes. Yeah, I think now it's better. Now it's a little bit better.
Okay, yeah. I hope now there is no problem. Yeah. Okay, so let's start our today's session again. So basically today discuss about that. I already create some material for our class. Okay, for today's session, which type of topic we discuss. So let me open. So I hope you already know about the machine learning. Okay, so we already discussed about the some topic on our 7 days training program for the machine learning.
Yes.
Okay, for make the land use, land cover classification, we also already discussed. So now we discuss about the deep learning and how to work deep learning. So all of those I try to explore. Okay, and then I hope you can really get the idea. Okay, so basically first of all, one thing is that very important: artificial intelligence. Okay, so artificial intelligence it's developing day by day, and a lot of GPT or Chat GPT is increased And all of those machine learning, deep learning, all of those are including in the artificial intelligence. Okay. So artificial intelligence is the head, all of those. Okay, machine learning, deep learning. So this is the subsection of the artificial intelligence. Artificial intelligence. So artificial intelligence basically is a field of computer science that refers to a machine's ability to emit and act like a human being in tasks they routinely perform. Okay. And machine learning is a subset. Machine learning is a subset of artificial intelligence. Okay. It is a program that can only learn it on its own and without human intervention, but also improve the performance with experience. So this machine learning we already discussed. Okay, a lot of topic, how to train our model, then how to learn our model. Suppose I have a satellite image. So this satellite image, I simply try to tease. This is the water body. This is the build-up. This is the vegetation. This is the suppose bare land. So then when I apply the machine learning, it can easily learn all of those from my model. Okay, and then make the land use land cover classification map for the whole satellite imagery. Okay, so this is the machine learning concept we already know. It's a subset of artificial intelligence. It's a program that can only learn on its own, okay, without human intervention, but also improve the performance with experience. Okay, but in this time, if you check learning, so deep learning is the most advanced method. Okay, it's the most advanced method of artificial intelligence. And it based on the technology called neural network. It's very important, neural network. Okay, so it based on the technology called neural network. So basically, for human brain have the neuron. Okay, human brain lot of neuron. So everything will be controlled from the neuron. So when you open your eye, you can simply check. You can simply see your data. Suppose when open your eye, you can see your laptop. You can see your text. Everything you can see by your eye. So your eye as the input. Okay, your eye as the input. So when I see anything, suppose it can be book, it can be anything. Then this information gone through my eye and go to my brain neuron. Okay, then it make the analyze and find out the pattern. Okay, so this concept is the neural network. Okay, which stimulate the behavior of the human brain at an extremely advanced level. And deep learning network as layers of the chain, suppose hierarchy method, are capable of analyzing more specific and complex information through the processing of the complex data. Okay. Suppose it's just like a human brain. Human brain have a lot of neuron. In this time, deep learning have also different types of neuron. So human eye, suppose human eye see anything. Suppose it can see text, computer, anything it can see. And this eye work as the input layer. Suppose human eye work as the input layer. And this data go to our brain through the eye, human eye. And in the brain have the lot of neuron. So then it further make the identify pattern, identify suppose different types of processing will be happened in our brain. And then we can easily recognize, we can easily find out anything. Okay, this type of it also happen for the deep learning. So this is the deep learning. It's based on the neural network, like as a human brain.
Just one doubt. This is our third class, right? In third class, what we are covering, can you just show me in the topic? I mean, what we are covering, so I can just note down.
So I will send you the PDF after the class. I will send you the full PDF. Then you can easily get the PDF and also learn more better. No problem. Okay. So I will send you all of material, so this type of material I created. And then I also send you in the Google Classroom. You can easily download and also you can read all of those more better, get the more better understanding about the deep learning. Okay, you can easily get all of those.
Okay. No, I mean in the course outline which is there on your website, which topic it is? I mean to say.
Okay, so basically this is our deep learning topic. Deep learning, basically introduction to the deep learning. Okay, introduction to deep learning. Introduction to deep learning. Wait, if you check, I already. So computer vision, artificial intelligence, drone and satellite imagery. Okay, and chapter one, basically the introduction to neural network and deep learning. Okay, so this is our module. So in the module, we discuss about the introduction to neural network and deep learning. This topic.
Okay. So I'm a bit confused regarding that because week 12, is it week 4 or week 5? I mean to say, which one it is? Because we completed numerical data analysis using Panda, and we are going with phase 2 or phase 3. That's what I'm a bit confusing. Core geospatial Python, or we are going with machine learning for geospatial application?
So we discuss about the deep learning application now.
Okay, machine learning using, okay.
No. Machine learning just show the example. What is the example about the machine learning, or what is the definition? But we discuss about the deep learning. All of those we try to discuss about deep learning. Basically, deep learning, how it will be work. Okay, because lot of model further future class we also explore a lot of model. Okay, there is lot of model we discuss. So that's why we try to discuss about the how it will be work. So all of concept we try to clear in this class. Okay. So now basic concept of the deep learning. So it's very important. So basically we already know about that CPU. CPU basically central processing unit. Okay, in our it's a brain of computers. CPU is the brain of the computers. But in the recent years, a revolution has taken place in computing. It's called the NVIDIA by NVIDIA. So NVIDIA is a company that has become an icon in the production of hardware and the gaming industry. NVIDIA realized that GPU basically typically used for rendering images and videos could be used to help solve computational intensive mathematical problem. Okay, GPU. So NVIDIA, this company, it just create the GPU. GPU like as a machine, okay, just like a machine, and it mainly help you to more computational intensive mathematical problem we can easily do using the GPU. And NVIDIA developed the general purpose of the GPU. It's called the CUDA. Okay, CUDA basically computer unified device architecture. CUDA, programming language. Okay, CUDA. And this CUDA enabling the use of powerful graphics processor to process the data. Okay, so from the embed system for home users to supercomputers, we can see the revolution of happening right now. So we can now write the code, interact with directly with GPU. Okay, so GPU and CPU, what is the difference between the GPU and CPU? So basically GPU, it can do more intensively mathematical problem. Okay, computational intensive mathematical problem. We can easily do the GPU. And GPU, if you check, GPU basically help you to get the GPU have the lot of core, you can see. Okay, so this is a CPU and this is a GPU diagram. So this GPU, if you check, there are a lot of core. Okay, there is a lot of core. And if you can CPU, you can see multiple core, only some multiple core. So this GPU have the 1,000 of cores, and we can easily do very big data set. We can easily do, and this computation power is very fast. When I apply the GPU, and CPU have not this type of computation power. Okay, so that's why we always use the GPU in our system. Okay, so you can see GPU basically GPU a parallel architecture consisting of the 1,000 of a smaller or more efficient cores to handle multiple tasks. Okay, and their application, we can easily use the GPU for including the image segmentation, image restoration, image interpolation, and image reconstruction. We also use the GPU. So GPU are the computer chip that perform mathematical calculation quickly in parallel. So this is the GPU and CPU. So CPU have some limitation. CPU have some limitation, but GPU have the 1,000 of cores, and we can easily perform lot of data, very big tasks, very deep learning tasks we can easily perform using the GPU. So now how I can connect the GPU? So this one system, it's called the, you can easily buy the NVIDIA software. Okay, GPU software you can easily buy and connect with your device. Okay, so if you check, so let me show you some GPU software, and then you can get the better idea. So GPU, about GPU price. Okay, just let me show you that. Mainly it's one kind of graphics card or GPU price. So let me show you that. Suppose So you can see the NVIDIA. This is the one kind of GPU. If you use this type of GPU, or you can easily connect this type of GPU with your computer. Okay, it's one kind of hardware. Okay, this hardware you can simply connect with our laptop or computer for performing the different types of deep learning model. Okay, you can easily use this type of GPU with our computer. So a lot of GPU is available. So if you can also, you can see it. Suppose your work is very task, then you can easily create the high GPU. Okay, GPU have the different types of high, low, medium. So different types of range we can see. You can see. So some GPU is the high price, some GPU is the low price. So you can easily use this type of GPU. It's a hardware. It's created by NVIDIA. Okay, NVIDIA company. Okay, that enables computational power very fast. So we can easily use this type of GPU. But suppose your system don't have any GPU. So then how I can work? Okay, so it also another possible. We can also work with the GPU without this type of hardware. So for that, we simply use our Google Pro. So Google Colab. So simply search here, Google Colab. Google Colab, I simply search here. So if you check this, the Google Colab. So Google Colab is also give you the GPU option. Okay, if you check it, how to connect GPU in the Google Colab, I will try to show you this process, because all time when I apply any deep learning model, you must need the GPU. Suppose your system don't have the GPU, but I want to connect the GPU with my Google Colab. So how I can connect? Okay, it's very important for our all time. We need to connect the GPU. Otherwise, deep learning model is not work. Okay, so that's why it's very important. So how to connect GPU with your Google Colab? Okay, so this is the code editor. You already know about this code editor. Okay, so we can easily put our name. Suppose I put the name is the first day. Suppose I put the first day, and this is the code editor. So this code editor have a one option to use the GPU. So how I can connect the GPU? Google Colab, I want to connect. So for that, if you check runtime, okay, runtime option, runtime. So in Google Colab, you can connect, use a GPU directly. No physical GPU connection is required. Okay. Google Colab provide you the cloud GPU. So it's called the cloud GPU. Okay. So I also write the name. So it's called the cloud GPU, cloud GPU. There is no connection with your hardware, with your software. It's a cloud. Suppose Google Earth Engine, we already know it's a cloud-based platform. Okay, there is not need any software, any hardware. We don't need. So everything will be controlled from the cloud, same like as the GPU. So it's called the cloud GPU. So in the cloud GPU, first time you can simply visit runtime. Okay. Then if you check the chaos runtime type, this one.
Yes.
Then you can see so you can see here different types of GPU, P4 GPU. So in this case, I am using the Pro version. Okay, so you can see it to the Pro because I am using the Pro version of the Google Colab. So that's why it show different types of GPU in my system. So GPU and also GPU. Okay, but you can see your T4 is only available. Okay, in your system, T4 is available. T4 GPU is available. Okay, but when you use the Pro version, so then you can see different types of GPU. Okay, you can easily get. I want to choose it. And then you can see the high RAM option also available because I already buy the Google Colab. It's the monthly subscription. Suppose $11 monthly subscription they are need. then we can easily use the cloud GPU, but freely available also, but freely have some limitation. Okay, freely have some limit of use of memory. So we can simply use it, this one, and then I just save it. Okay, just save it. There. So now you can see it connect T4 high RAM. It's connecting. So now I want to check. GPU is available or not. I want to check it. So for that, we simply import a library. It's called the torch library. So import PyTorch. So it's called the torch. Import torch. So just I run it. So it's importing the PyTorch library. And you can see it also show the T for high RAM. Okay, so now it's connecting, okay, with my device. So it also imported. So now I want to check the version. Okay, I want to check the PyTorch version. So for that, I just print. I want to print, suppose, PyTorch. Suppose PyTorch version. I want to check PyTorch version. I want to check PyTorch version. So I just call the library torch. Dot. Version. So now run the code. So if I now you can see there's a PyTorch version. Okay. And now I want to check in my system, CUDA is available or not. The CUDA. What is the CUDA? If you check, I already show you the CUDA. So CUDA, if you check the CUDA basically it is GPU and the CUDA basically computing unified device architecture. Okay, programming language, enabling the use of powerful graphic processor and process data. So now I want to check in my GPU, this CUDA is available or not. I want to check it. Okay, it's available or not in the CUDA. So let me check CUDA is available or not in my version. I want to check it. So how I can check it? So for the CUDA, I simply check it. And before that, I want to check suppose GPU. Suppose I want to print GPU is available or not. Suppose GPU. So this is the GPU available. It's or not. I want to check it. So for that, I simply write here. I simply call the torch CUDA is available. So this is the function torch. So basically, I simply call this library torch. CUDA is available. I want to just put it. So now let's check what is happened. Yeah, true. It shows that true. Okay, true means that GPU available. Okay, it means that. So when I put the GPU torch CUDA is available, if it shows the true, it means that GPU is available in my system. Okay. So now I want to check another. I want to check the GPU name. Okay, GPU name, I want to check it. I want to check the GPU name. Okay, so I want to check the GPU name. So if torch CUDA is available, then I want to print. Suppose I want to print GPU name. Okay, so I want to print device, right? I want to check suppose GPU name. So how I can check the GPU name? So I want to put GPU. Then I put the torch CUDA get device name. Okay, torch CUDA get device name. So just I use it. Dots CUDA get device name. So now it show me that if the CUDA is available, mainly I already check CUDA is available. It show that true. So now I want to check in my GPU name, okay, because it's already available. So I want to check it. So it show the GPU name is the Tesla 4, Tesla T4. This is my GPU name. So first of all, I simply import the library, import torts. Then I simply check the torts version. I find out the version. Then I simply check the CUDA is available. CUDA mainly GPU. Okay, GPU and CUDA. So I already discussed all of those in here in the PDF. So you also try to read this type of things to get more better idea. What is the CUDA? What is the GPU? All of those you can easily get the idea. So we try to check it. Torts CUDA is available. It show the true. Okay, if it's available, then I want to check the name. Okay, so I find out the name is the Tesla T4. Okay, so very easy. We simply check our GPU name and we also connect with our GPU. So this is the one way we simply check it. Okay, as well as another way we can also apply. It's called the check. Okay, I'll write it. It's called the check the GPU using NVIDIA tool. We can also check the GPU using the tool. So this is the one way. Simply check the tool of GPU, as well as you can also apply another way. It's called the NVIDIA tools. NVIDIA tools. We also check it with the GPU. So how I can check the GPU using the NVIDIA tools? So further we simply apply NVIDIA SMI. Just run the code. So you can see now it shows me all of information about my GPU. We find out that. So you can see the Saturday for time. Okay, Saturday, August. This is the time. We find out that NVIDIA SMI version, driver version, CUDA version. Okay, CUDA version, GPU name. Okay, you can see the fan temperature. We find out that bus ID. So version. So all of information you can see. So how many percentage I use? Okay, I have not used any percentage yet. So basically in this time, we are not running any process. Okay, any computational process is not happened. So that's it. So the no running process found. Okay, because in this time we are not running any code. We are not running any deep learning model. Okay, so that's why it shows this type of things. No running process found. GPU, all of those we find out that GPU memory uses. Okay, so you can see 0% we are just use. It's a Tesla T4. Okay, Tesla T4. So all of information you can easily get using the NVIDIA tools. So NVIDIA.smi. Then you can easily get all of information about our GPU. So now we discuss about the another. So it's called the TensorFlow. Okay. So for TensorFlow, how to check TensorFlow? So TensorFlow, if you are using TensorFlow for different types of library, suppose CNN, convolution neural network, UNet, then deep lab V3, segmentation. So we will also discuss all of those step by step. Then you can get the better idea. So now I try to show you that how to import the TensorFlow and how to check all of those using the TensorFlow. Okay. So for that, you simply import one library. It's called TensorFlow. TensorFlow as a TF. So I simply import this library, TensorFlow as a TF. So you can see it also work. There is no problem. So I want to check the GPU information. Okay. So for that, I print TF TensorFlow that config list physical device GPU. Okay, this one. TF TensorFlow config list physical device GPU. I need to check it. So you can see it with the physical device GPU. Device type is the GPU. We find out that. So it means that we find out the GPU in our system, also TensorFlow. Okay, and TensorFlow we are using for different types of work, suppose CNN, UNet, Deep Lab V3, and segmentation. So further, we also discuss more details about that. Okay, so this is the way how to connect your cloud GPU. Okay, cloud GPU with your Google Colab. So you can easily buy. Suppose if you check the runtime and you can see the change runtime. So here you can see the purchase option. Okay, if you don't have the, suppose first time not need, but when you go to the further big class, or we are just use the more lot of data or big data set when you work, then you also try to buy the GPU to get the more computational power and also get the more memory, okay, to use the work, because sometimes it show the memory limit exists, sometimes it show the different types of error, okay, without high RAM GPU. So that's why you also try to buy this GPU when you do the course, because a lot of computational things will also work. So that's why it creates some problem when you work on your own side. Okay, so you also try to buy in the course, then it also help you to learn more better all of this. So monthly $11 only, you just try. Or it also better, you can also connect your physical hardware or software with your computer. It also more better. Okay, so this process I'll show you the further. If you buy any device, then I'll show you that. In this time, my laptop, I am just using the cloud GPU, and I am not have the any hardware GPU in my laptop. So that's why I am not showing this process. But it also possible to use the hardware GPU when you connect with your laptop or computer. So now we are using the cloud GPU and do all of work, okay, in this online training program. But it also possible further in India, if you buy any GPU in your system, then you can also inform me. I will show you the process, how to set up the GPU with your local hardware. Okay, I'll just show you that, inshallah, no problem. Okay, these things is very important. We discuss about that. So how to connect with the GPU and CPU. So GPU is, we just simply connect in our Google Colab in the cloud GPU. So now we discuss about the big data. So big data, you already know about that, the concept of big data. It's a okay, let me open PDF. The concept of the big data, this one. So big data in its simplest form can be understood as the collection, processing, and analysis of vast amount of data, represented in different format and types, and originating from different diverse source, which cannot be processed using the traditional analytical tool. Since everything on the internet can be measured and quantified, we can say that everything on the internet is potential data. So big data, basically it's indicating about a lot of data. Okay, suppose a lot of data, it's just collect drone imagery. Okay, so I have drone imagery. So this drone imagery we need to upload, or we need to processing, or we need to analyze this type of drone imagery. And one drone imagery is very big. Okay, it's very high. Suppose 2 GB, 3 GB, 4 GB, 10 GB, 20 GB data. Okay, so this type of data called as a big data. Okay, big data, we can, when you apply, then we need the big RAM. Okay, so GPU is very important for that. Okay, for immense amount of data, and then when you analyze, okay, then we need the big GPU. It's more better to work. Okay. So further we discuss about this type of big data more. So how to collect the big data, or how to upload the big data, how to processing the different types of big data. Okay, then you can get the more better idea about the big data. Okay, so you also later. So in this time, this is the advance in academy. So in the mid 1800 to 1990, many significant advances were made in the architecture of the artificial neural network. So the amount of the time and data required to achieve the good result showed adoption constantly internet, so known as the AI winters. So in that, so it shows the history sum. So now what is the advantage of the deep learning? Okay, what is the advantage of the deep learning? So deep learning is the autonomous. A deep learning model learned without mass guidance. Okay, unlike machine learning. So machine learning, we need to guidance. Okay, lot of training sample we need to input in the machine learning concept. okay, to get the more better result. But deep learning, without mass guidance, it works. Suppose I simply input some label, then it will be work. But machine learning, when you apply, you need the lot of training sample, lot of guidance, lot of supervise. Also, we need to apply for the machine learning. Which is automate only a certain extent. And deep learning requires more data. So it's very important. Deep learning requires more data to improve their accuracy. So when you need the better accuracy, you need the more data. And deep learning model need more data than machine learning models. Okay, deep learning models need more data than machine learning models because they use the structured data and can be really on the similar volume of the input. Okay, and deep learning has more complex application. Okay, deep learning has more complex application, and deep learning is used in more complex and sophisticated applications such as virtual assistant, chatbot, or fraud detection, where machine learning is not applicable. Machine learning is, on the other hand, since it different on level data, is not applicable for solving complex problems that require large volume of data. But deep learning is self-correcting. Okay, it's very important. Okay, deep learning is self-correcting. Okay, it's self-correcting, and in the case of incorrect prediction, a deep learning model can determine, okay, as well as also a prediction is accurate or correct itself if it is not. So it can easily identify. And deep learning is a self-correcting. Okay, this is the best advantage to use the deep learning. Suppose if the any error or any issue, then it easily correcting by self and then make you more better result. So this is another advantage to use the deep learning. Okay. So now we talk about the perceptron. Okay, perceptron is very important. Okay, so perceptron, it's in 1958. Okay, Frank Rosenfeld introduced the perceptron artificial neural network. Okay, so perceptron, it's called the single layer artificial neural network. Okay, and it's in 1958, Frank Rosenfeld introduced the perceptron, inspired by the work of Walter Pitts and Oran Strasmacher. This is the person. Basically, this model is one of the oldest, okay, and deals with a single neuron. Okay, so it's not the multiple neuron; it's a single neuron. Okay, perceptron work is for single neuron and classifying the output linearly. Linearly, it's very important. Linearly, it's a single neuron, and it classified the output linearly. In the following figure, if you check, the artificial neuron is a perceptron. Okay, basically, perceptron is the name. Perceptron is the name of single neuron. Single neuron called as a perceptron. Okay, single neuron called as a perceptron, and it's a linear. But we have also another. It's a non-linear. So further, we'll discuss about that. The perceptron is a linear. If you check the figure, here we find out the input. You can see that was x1, 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 x1. So different types of input. And we find out the weight. W1, W2, W3, W4. Then it's a just identify, just simply create the summation and this x1 multiply w1. Okay, summation all of those. Okay, and plus with bias and with a summation and bias in this part. After that, we simply create a activation layer. So it's called the activation, and further we simply get the output. Okay, result. So if you check in this case, the artificial neuron is a perceptron that receives the several input values. So it receives the several input values, and this input are multiplied by the synapse weight. Okay, so it's called the synapse weight. W1, W2, W3, W4. It's a synapse weight. So this input is multiplied with synapse weight. And these inputs are multiplied with the synapse and finally summed of the form of the set input. So it just create this type of summation and this result is passed through a linear activation. Okay, so this result passed through a linear activation function generate in here, and when the values exceed the threshold of the activation function, when it exists the threshold value, then it will be active. Okay, then neuron will activate and return a value. Okay, so in this case, several input just come in our, and also multiply with our weight, synapse weight, and create the summation, and then it just simply come in the activation function. And when it exceeds the limit of threshold value, okay, suppose we have a threshold value, so when it just cross the limit of the threshold value, then our neuron will be active. Then neuron will be active and return a value. So it called the single layer perceptron. Single layer perceptron. So in this case, input, weight, summation, and bias, activation, and output. So further, let's discuss this type of topic more. Then you can get the more better idea for the uh, neuron layer. Okay, single neuron layer. It's called the perceptron. Okay, so in the meantime, we simply make a break for the prayer time. Okay, so now it's our prayer time. So after after 20 minutes, we will meet again. Okay, so just for 20 minutes, where we'll try to meet again and then discuss the further topic.
Okay.
Okay, because okay, it's gonna prayer time. Okay, thank you.
Okay.
Okay, welcome back. Can you hear me? Hello.
Yes, brother.
Okay, so now we continue.
Brother, yeah, just I have one doubt, brother. I was just going through the last class. We completed this week 3 and week 4 classes. I mean, what?
Week 3 and
I
week
mean,
4.
in week 3, yes.
But the last
Can
class.
just yeah, we did week 2 class 2, right? Can you just check that one because I'm just going through after the but it just
Oh, I think I understand that. So basically, okay, so this topic we also complete later. So basically, this is the
yeah
your geopandas. Okay, some geopandas
yeah
of
yeah yeah
operation.
week 3. Yeah, I
Yes.
was I was just going through that one. Like we did not go numerical computing with NumPy and then
Yeah, yeah, understand, understand,
pandas.
understand. So basically, okay, no problem. We'll also discuss later for this part, other part, no problem. So this
Yeah,
is the
I was
basically
confused why we left this one.
this
Okay,
is
okay,
the
no problem.
geopandas
Yeah,
for creating the different types of mapping. Okay, using the geopandas.
yeah, yeah.
Okay. Okay, no
Yes,
problem. We
yes.
also discuss later this type of topic, no problem. So it's a similar, but not okay. We'll also discuss, no problem. So today we discuss about the deep learning again.
Okay,
So we also discuss this type of topic later. Again, no problem. No problem.
okay. Because we left with
Yeah.
something like raster, like for week 3, raster like matrix operation, numerical transformation for satellite data,
Yeah, yeah, yeah,
and
yeah.
again for week 4
Understand.
also rainfall trend analysis.
Okay, no problem. We
And
discuss.
okay.
Okay, we discuss. We discuss all of topics. So basically, it's our total. I think. Okay, let me check the.
Well, I was
Okay.
confused why we are going with deep learning suddenly. I was asking that one only because we completed till week 2 only.
All will copy, no problem. All content will be completed, no problem.
No
Let
problem.
me check the our course content. Let me check.
The pattern is changed actually. The course pattern is changed again. I'm just saying. Okay, in the chat box I send you. In the chat box I send you. It is in this way. In the chat box, can you see?
Just
It is changed now. The pattern is changed of the website. In the chat box I send you the link. Yeah, this one.
okay. So Python foundation. We discuss about that.
Yeah, functions and file
Numerical.
handling
Okay,
is
understand,
completed.
understand. So core
Week
CRS,
3.
raster processing, time series, machine learning,
Yeah, this is
geospatial.
the
Okay, machine learning, many project, computer
yeah
vision.
we left these options.
Okay, so now we discuss this from here. Yeah.
Yeah, we went to 19 suddenly. Why we
Yeah,
went
yeah, yeah.
here?
Okay, no problem. It's not a problem. Not a problem. Not a problem.
Okay.
So first of all,
Okay.
suppose just you simply check the content. Okay. So deep
Okay.
learning, we need some foundation. Okay. It also covered this
Yeah.
type of topic also. Okay. So that's why I just jump
Okay.
in here. So basically, deep
Okay.
learning and the previous is not for the deep learning. So basically, this type of concept we also later we discuss. No problem. Okay. So you simply
Okay.
remark
So
all of
we
topic which I teach you.
yeah
Okay.
yeah week 1 week 2 is completed. From week 3 we have to start it actually.
No problem. It's not a problem. It's not a problem.
Okay.
Not a problem. So we get deep learning. So I can see 2 weeks. CNN, PyTorch, and then deep learning, geospatial AI. You can, okay. So this
Yeah.
this type of topic is more conceptual. Okay, so that's why I think it also better to first of all we try to discuss this type of topic. Okay, we try to then we just jump to the other topic. The other topic is not much hard. So it's very easy. We go to very quickly all of those. And this type of topic is not have much theory. Okay, but deep learning have a lot of theory. And I also give you some reference book also. Okay, I have some lot of book. You also try to read it. Then we try to discuss this. It's no problem. Deep learning. Let's continue. So this is we're discussing here. It's perceptron. So do you want to learn more deeply or just I simply read and then show you the example? What you choose? Do you want to learn deeply all of those or just I will show you the code and then discuss? This one is better for you.
Because this is first time now. So GeoAI it will be very because it understand.
You go to the deeply all of those. It's more better.
Yes.
Okay, deeply. We deeply discuss all of those because it's very conceptual. And without deeply, you cannot be developer. Okay, so when you develop, and if I show you the ready-made code and show you the ready-made all of those, then you cannot become a developer. But when you understand all of those, then you can easily become a developer and you can easily apply this type of code in the other analysis. Okay, it's also better, I think.
Yes.
Yeah, so it's better. So now we talk about the perceptron, and now we show you an example about the perceptron. Okay, how to work with the perceptron in our real world. Okay, or real data. So perceptron, I again simply explain. So perceptron have some input. You can say x1 in this type of input, and this type of synapse weight. So this input and synapse weight, we just need to create the summation. After the summation, we simply set activation. In the activation, we set a threshold value. When this threshold value will be exit, then our neuron will be active and then make the classification. So if I show you one example, theoretical example, then you can get the better idea how it will be work. Yeah. So okay, let me write some code also for the single layer perceptron. Single layer neuron. Basically, single layer neuron. It called as a perceptron. Okay, perceptron. So now how it will work for the practical example, I'll show you that it will be more better. Suppose I have some data. Suppose I simply import a library, import NumPy. NumPy is a library. Basically, it's handle the array, 2D array, 1D array. So NumPy is a Python library used for numerical calculation. We use it used for numerical calculation. Numerical calculation. I also set some comment. And we put the short name, suppose in NumPy as NP. Okay, so that's I put the short name as NP. So NumPy. So now I simply take a variable, suppose X. I take a variable X and I simply call my NP and I want to create an array. From the NumPy function, I call the array. From the NumPy library, I call the array function. And I simply define a one data. Suppose I have a data. I have suppose this type of value. Suppose what I can write. Suppose I have the data 0, 0. So this is the one. Suppose I have the another data. Suppose 0, 1. Then suppose I have the another data. Suppose 1, 0. Suppose I have the another data 1, 1. So suppose I have this type of data. Suppose, oh my god, what is the problem? We need to use the comma sign. Okay. Need to use the comma sign. Now, what's the problem? This function method is supplicable building a function or method. Okay, we need to put the parenthesis. Okay, so NP function, then put the parenthesis. So now it will work. Okay, done. So if you check, just I print the X. we find out this type of data 0, 0, 1, 1, 0, 1, 1. Suppose I have two class. 0 suppose water, 1 for build up, or any binary class 0 and 1. I have some data. It's including some 0 and 1 class. So now I want to apply. I want to apply single layer neuron, and then I classify. Okay. So how I can do it? So let me show you that process. So this data can be anything. Suppose partner, when you show you the real example with satellite data, then we simply use some satellite spectral value or band pixel value or satellite image data to classify it. Okay. So now I show you this type of, suppose 0 and 1. 0 suppose one class, 1 for the another class. Suppose this 4 observation, if you check input 0, 0, 0, 1, 1, 0, 1, 1. Suppose I have total 4 sample. 4 sample. Okay? I have total 4 sample. X is the input. It's my input. It's an input feature. And then this row, suppose this type of row indicating about the training sample. Training sample. It is also better. Let me show you the Excel file. Then you can get the better idea. Just a minute. Suppose I have a one column. I have a one column for sample. Sample. I have one column for sample. One column for input. Suppose input 1, another column for input 2. Okay. Suppose I have the sample 1, 2, 3, and 4. And I have the input, suppose first input 0. Second input, let me check. Second input also 0. Mainly 0, 0. Then first input 0. Second input 1. Then 1. Then 0, then 1 and 1. So I have this type of sample and this type of input 1, input 2. Suppose 0, 0, 1 input 0, 1, 0, 1, then 1, 0, 1, 1. So I have this type of input. So now I want to apply. So here you can see we find out that is row 1 training sample. So this is row 1 training sample. This is another training sample. This is another training sample. This is another training sample. And each column 1 feature. So it's a feature. It's a 1 feature. This is the another feature. So row represent as a sample, 1 training sample, and column represent as a feature. It's a 1 feature. This is the another feature. Okay. Feature, we already know about that. We already know about the band 1, band 2, band 3, band 4, this type of feature. Okay. And this type of call as a sample. It's a sample. It's a sample. It's a sample. It's a sample. Okay. Row is the sample. Column is the feature.
Okay.
So now we try to identify target output. So what is our target? What is our target? We try to identify. Okay, what is our target? So this target, suppose we simply create another variable y, and we define our target. So y, I put suppose np array 0, 0, 1. Suppose this is our target. This is our target. If I show you that, suppose y, suppose 0, 0, 1, this contain the correct answer. Suppose this is my target. Suppose 0, 0, 0, 1. So this sequence I want to gain from this data. Or this is my target. And this is my training sample or feature. And this is my target. Okay. So this target. So now, suppose you already know about that logic. Logic basically and, but, or. And, but, or. We already know about the logic. Suppose in this time, you can see, I have the data 0, 0, 0. But I want to get the output 0. So, which logic I want to apply? Suppose I have the data 0 and 1. But my expected outcome is the 0. So, which logic I want to apply? I have suppose 1, 0. But my expected is the 0. So, which logic I want to apply? Suppose I have the 1, 1. My expected outcome is the 1. So, which logic I want to apply? So, in this case, we simply apply the AND logic. AND logic. AND logic. So, if you check, okay, let me open. And I also add another column. Suppose expected outcome, output, expected output. I simply put in here expected output. Suppose 0 and 0. So when I put suppose 0, 0, then if I put my expected output is the 0. Okay, then 0, then 0 and 1. Okay, so when I apply the AND logic get, AND logic get, then we find out this type of expected output 0, 0, 0 and 1. So I think, okay, let me show you the some source about that. So AND logic get, if you check. So AND get. We also did get more better from here. You can see AND get, you can see. Okay, so you can see the AND get. AND get is a fundamental digital logic that perform the logic multiplication of two or more binary input. So the output of an AND gate is high only when all the input are high. Okay. If any input is the low, then output become the low. If you check, we find out that input 1 and input B. So 1 and 0, but AND logic give me the output 0. So when I put the suppose 0 and 1, it shows the 0. When I put the 0, 0, it shows the 0. When I put the 1 and 1, then it give me the result 1. Okay, so AND gate is represent the logic multiplication of its input, the dot. Okay, suppose X equal to A and B, just multiply. So in this case, you can see we simply apply the multiply. So if you just simply multiply, if you check, suppose 1, 0, 0, multiply, you find out the 0. 0, 1, multiply, you find out the 0. 1, 0, multiply, you find out the 0. 1 and 1, multiply, then we find out the 1. So this is the AND logic. X equal to A multiply B. So this called the AND logic. Okay, so I hope you also get the idea about the AND logic, how it will work. So in this case, we simply define the two variable, X and Y. X basically it's our training sample or feature, and Y is our target. So I'll write it's a target. So it's a Y is the target output. It's a target output. Target output. Target output. Okay, so we define X and Y, target output. Okay, so now, so this is the X and Y. So now we simply initialize the weight. Initialize the weights. Initialize the weights. So we take a variable. Weights. I call the NP dot. Just apply the zeros. So now further I want to check the result. It show the 0, 0. Okay, 0, 0. Why 2? Because we have two input feature. Okay, so we have the two input feature. That's why I put the 2. So you can see initial the weight. So I put the 2 in here because this creates the two initial weight 0, 0, weight 1 and weight 2. And mathematically, we simply write it. Suppose mathematically we can still write suppose summation or Z equal to x1 w1 plus x2 w2. Summation we simply apply this equation now, which will be applied. So now we have the weight and also have the input. The model with later than better values we simply apply. As well as we also need another one. It's called the bias. So we simply initialize the bias. BIAS bias. It also need bias. Basically, the bias is another parameter of the neuron. Okay, so bias is the another parameter of the neuron. in the neuron, we also need to set the bias. The complete equation, when I add the bias, so what I need, the complete equation will be this equation. So we simply connect the bias. So complete equation is this z equal or summation and also plus bias for b for bias. Okay, this is the complete equation. Okay, initialize the bias, and then we simply this is the input, and this is the synapse weight. This is plus, this is the input, this is the synapse weight, and plus b mainly bias. This is the another parameter of the neuron. So here we find out the H is the input, W is the weight, B is the bias. Okay, so we simply say suppose initial bias, we put the 0. The initial bias, we set the 0. So this is the bias we simply set. After the learning rate is very important. Learning rate. Okay, so it's very important. Learning rate. So learning rate control how much the weight change during the learning. Okay, learning rate basically it controls how much the weight change during learning. It's called the learning rate. So we simply set learning rate, suppose learning rate equal suppose 0.1. Okay, so learning rate 0.1, a larger learning rate means larger update. A smaller learning rate means that a smaller update. Suppose learning rate equal 0.01, it's indicating the small update. Okay, small update. Learning rate 0.1, it's indicating about the moderate update. And learning rate 1, it's indicating about the large update. So learning rate is very important because learning rate control how much the weight change during the learning. Okay, how much the weight change during the learning. So if I put the 0.1, it means that moderate update. Okay, so large learning rate means the large update, and a smaller learning rate means the smaller updates. Then it's that another important, it's called the epoch. Epoch is very important for the learning. So it's called the number of epoch. So number of epoch. Number of epochs. So a epoch means one complete pass through the entire training dataset. Okay. Suppose an epoch means one complete pass through the entire training dataset. Okay, training dataset. We have 4 samples. Okay, so an epoch means that one complete pass through the entire dataset, full dataset. Okay, so if I put the epoch, suppose epoch equal 10. So if I put the epoch is the 10, so the perceptron goes through this 4 sample 10 times. Okay, the perceptron goes through this 4 sample 10 times. Therefore, we find out the total how many iteration. Suppose 4 sample, we have total 4 sample in this time. Suppose 4 samples, it's multiply with 10 epoch. 10 epochs. So we find out that total 40 training iterations. Okay, so when I put the 10, it means that I have total 4 training sample. So this 4 sample into 10 epoch is equal to 40 training iteration. Okay. So after that, we also need to another one. We need to define the activation function. define the activation function. Define the activation function. So define the activation function is, so we simply define, so take a very function, suppose take a function def, I put suppose activation. I put the variable name activation and I put the element name jet. Then we simply put our argument. So activation so here we create the function called the activation. Okay, we call the function name is the activation and it received the values in the jet. Then it check, suppose if jet less than equal 0. This check is the calculate value jet greater than or equal to 0. If yes, then it execute the next line. Okay, and return 1. So if the value, if the jet less than equal 0, the neuron produce 1. This is the positive class 1. Okay. Or else suppose return 0. If the value, if the z value less than 0, the neuron produce 0. So the activation function, we find out that 1 and 0. Basically 1, if the value greater than equal 0, then we find out the 1. And if the value z less than 0, then we find out the 0. This is called the step function. Okay. Okay, there is no problem. This is called the step function. So now, if you check here, I again explain. So first of all, we simply create the data. Okay, suppose x and y. X basically input or feature. And further, we simply find out our target output 0, 0, 0, 1. Okay, this is the target output. We simply apply. Then we simply set our weight. And also set the bias. We set the bias. Then we find out the learning rate. Okay, and also set a step activation function. We simply define the activation function. Okay, so in the activation function, what we said? We said that if the jet value less than equal 0, then it return 1. Or if the value less than 0, then it show the 0. Okay. So this type of all time, not only for that example, all time, when you work with any layer, any perceptron or any artificial neural network, this type of things we need. Suppose we need the one data, training sample, we need the predict or expected output data or target output, we need the weight, as well as we also need the bias, we need the learning rate, we also need the activation function. Okay, it's a common. Okay, all time we need this type of things in the different way. When you apply any one artificial neural network or anything, when you apply for artificial neural network, we need it. So now how I can apply? So let me show you that. So now training. So training, we apply the total 10 epoch. Okay, 10 epoch. 10 epoch. So for the 10 epoch, I just create a loop. So I create a loop. And this loop apply. Okay, 10 times. So further is simply a variable was for epoch in range. epoch in range, and then call the epochs. We already defined the epochs. You can see 10 times. So then just I paste in here epochs. Okay, as well as we also define numbers for I in range. How many times? Basically 4 sample. I have total 4 sample. So just I call the len and define the x. X basically it is my 4 sample. So this 4 sample, I apply the 10 epoch. Mainly total 10 into 4, 14 iteration will be done in this time. Suppose epoch 10, x is my sample, 4 sample. So epoch multiply with sample 40 times. It create this type of things. So then we need to calculate weight sum. Okay, we simply have calculate weighted sum. So further I take a variable called z equal np dot, I just call x is my input. Okay, x is the input, and these things multiply with weights. And then class with bias. Okay. So now we simply calculate the weighted sum using this formula. We simply calculate it. So now we simply prediction. So let me try for prediction. So prediction. In this case, take a variable, suppose prediction equal, I just call the activation. I just call the activation. It's come from this function activation. Okay, activation. Then I call my data. This is my data. Basically, this is the calculate the weighted sum. Just I simply apply the activation function. Okay, if you check the chart, so I simply computed W1 X1 summation, then plus bias. I already done. So now I simply apply the activation function. I simply apply activation function. So for that, how I can apply, you can see. Just I call my activation, because you can see I already create the function of the activation. Just call the function variable name and connect with my weighted sum data. Just connecting. Okay. So after that, we create the error. So calculate error. So for the error equal, we just call our target data y. Target data we simply call minus prediction. So now we simply update weight. So update weights. So how we can update? So update weights, it's connecting with your learning rate. So for that, I simply take a variable. Suppose I call the variable name is weights. Weights equal, I just call weights, W-E-I-G-S-T-S, weights. It's plus with learning rate. Then it's multiply with error. Then multiply with our training sample X. Okay, language training sample. So update weights, then update bias. So now simply update bias. So update bias. So how I can update my bias? So take a variable bias and call your previous bias plus with learning rate. learning rate plus error. Okay, we simply call it all of those. So now finally we simply print, some information, suppose epoch, then also weight and also bias. We simply print. So print epoch. I want to show the epoch. It's come from this epoch variable +1 and put this type of colon sign. Then I also want to print, suppose weight. Weights equal weights, comma. I want to print suppose bias value also. So bias. So bias equal bias. Okay, so now it prints type of things. So now run the code, what happens, you try to check it. So you can see, find out this type of, you can see it create total, you can see epoch. Okay, so you can see epoch 1, 1, 1, 1, total 40. We find out total 40. Total 40. Because we have total 40 sample. We have total 40 sample. So it computed as well as weight. Okay, and find out the bias. Compute the bias for each class. Try to compute the bias. Okay, so and create the total 40. You can see total 4, also 4, total 4 into 10. Okay, so it creates also information, epoch, then weight, and also bias. We can see this is the function. So now we try to apply. Okay, let me click the apply. With our prediction. Suppose I want to print prediction. What I prediction? I am to prediction all sample. So further is simply create a loop. Suppose for sample in X. And then further I simply call the Z and call the NP dot. I want to multiply, so put the dot function between sample and weight. So sample and weight, between sample and weight, and plus bias. Okay, and prediction using the activation jet. And further we simply print sample, then prediction. Okay, so now nothing. So you can see, find out that all of those. So input, when I put the input 0, 0, it predicts 0. Okay. When I put the input 1, 0, 0, 1, it shows the prediction 1. Input 1, 0, prediction 1. Input 1, 1, prediction 1. So we find out this type of final output, sample to prediction. Or you can also represent, suppose we simply apply another format. Suppose just I print sample, only sample, then prediction. Sorry. So again, we find out this type of output prediction 0 0. Then we find out the 0 0 1 1 1 0 1 1 1 1. We find out that. Okay. So this is a normal perceptron neural network. How to apply? We discuss about that. So you can see. So we have the some data. So this type of data have the x and y. Okay. And further we simply y is the target, x is the training sample. So we simply set the weight, and we also just mathematical. This is the equation of the weight, and we also set the bias. Okay. Then we simply connect with our bias and also learning rate and epoch and also activation function, and further we simply apply in our data, and then further we simply just apply all of our data. So then we find out this type of prediction 0 0 1 1 1 0 1 1 0 1. We find out this type of prediction. So this is the one kind of normal perceptron or single layer perceptron, okay, for our model. Basically, this is the example for this type of model. The input, also your synapses weight, just multiply and also put the summation or bias and also call the active function and then also identify this type of things. Yeah. So you also try to read all of those more better. I also send you some reference book also. Then you get the more better idea how to work this type of things and get the better idea also. So now we discuss about the neural network. So it's called the neural network. Perceptron, it's a neural network. Okay, perceptron is a neural network, but single layer, only single layer. It's called the perceptron. But artificial neural network, we already know about that. Artificial neural network are the set of algorithms inspired by the working of the human brain. Okay. Typically, when you open your eyes, what you see is called the data. Okay. And it's proposed by neurons when the data processing cell in your brain and allowing it to recognize your environment. This is how neural network work. They take a large set of data, process it, and extracting the pattern from the data. And neural networks, sometimes called the artificial neural network, are not natural like neurons in your brain. Okay, they artificial mimic or natural or functioning of the neural network. So this is the artificial neural network. So we simply apply different types of neurons. And if you check, it's very important, layers of neural network. Neural network have the different types of layer. One is called the input layer, and another is called the hidden layer, and another is the output layer. Okay, so input layer, hidden layer, and output layer. These three layers create the artificial neural network. So what is the input layer? So you can see input layer, the first layer of the receives raw data. Okay, so it's work as your eye. Okay, it receives the raw data from the outside world. Each neuron or node in this layer represent the single feature in the data set. This layer performs no math or calculation. It just passes the data forward. So you can see it receives the raw data. Each neuron correspond to the feature in the data set, does not perform calculation, only forward data. Example, in an image, each neuron can represent a pixel value. Okay, suppose I have the input layer. So this input layer, it just simply receive your data. Just receive and forward to another second step. So it's the input layer. Then hidden layer, if you check hidden layer. So hidden layer, the intermediate layers that sit between the input and output layer. The input and output layer, we find out the hidden layer in the middle portion, in the middle hidden layer. So hidden layer, this is where the core computation happens. Okay, so hidden layer, it's compute the core computation. Okay, I think some out noise from your side.
Sorry?
Some out noise.
Okay, let me just.
Okay, kindly mute
fan.
Okay. So this, the intermediate layer, so this the hidden layer is very important because all computation happen in this hidden layer. All computation. Neuron apply weight or bias, active function to find out complex pattern. So weight, then bias and active function, this type of process happen in the hidden layer section. It locates between the input and output layer, perform the main computation in the network, apply weight and bias input data, and use activation function to reduce non-linearity. And number and size depend on the complexity of the task. So this is the task for hidden layer. And output layer, what happened? So output layer, the final layer that produce the network's prediction, score or classification. Okay, we find out the output layer. The number of neurons here depends on the specific problem, such as one node for recognition or multiply nodes for category classification. Okay, so this layer produce the final output or prediction. Number of neurons depend on classes. Uses different activation function. Okay, softmax or multi-class classification, sigmoid or binary classification, and linear for regression. Okay, it's happened in the output layer. So these three layers create the neural network, and it's very important hidden layer, because in the hidden layer it compute all of those. Okay, suppose it computed different types of bias, weighted bias, learning rate. So all of those happened in the hidden layer. And output layer, basically it show you the result or classification or accuracy. This type of things happen in control output layer. So hidden and input layer is just a raw image it received, raw data it received, and forward to the hidden layer. And all of those happen in the hidden layer. And finally, we find out the output layer. So now this hidden layer, it can be classified different category. So now we discuss about the hidden layer category. So in the hidden layer, if you check types of hidden layer in artificial neural network, one is called the fully connected layer. Fully connected layer. So densely or fully connected, dense layer or fully connected layer. So dense layer is the most common hidden layer. Each neuron is connected to every neuron in the previous layer. So every neuron is connected, okay, with in the previous layer, and it performs the weight of sum input followed by activation function to learn complex pattern. So densely, you just remember that it just simply connected all of layer. Every neuron is connecting in the previous layer. Okay, and perform the weight of sum input followed by activation function to learn complex pattern. You can see I also shorted. Each neuron is connected to all neuron in the previous layer. Perform the weight sum input the applied activation function. Activation function like ReLU, sigmoid, and other learns important representation from the data. So this is the, it's called the densely layer. Okay, densely layer or fully connected layer. So it's the one kind of hidden layer. After that, convolution layer. It's very important. Convolution neural network we can also apply for image segmentation or image classification, or also different types of way we also apply. So further we also discuss more practical example, then get the better idea. So convolution neural network is used in the neural network, especially CNN, okay, to produce image and special data by capturing important pattern and feature. So it shows the one kind of example. So you can see source of pixel. Suppose this is the one pixel. It's including 0, 0, 0, 1, 1, 1, and 2. So it's identify convolution kernel. Convolution kernel and identify suppose 0. And new pixel value, suppose destination pixel. It's identify suppose this one -8. Basically, center element of the kernel is placed above the source pixel. The source pixel is then replaced with the weighted sum of itself and nearby pixel. And it applies for convolution operation using filters, mainly kernel. It can input data to center feature map, capture the special feature like edge, texture, and shape, reduce the parameters compared to fully connected layers, and widely used in the image and vision related tasks. It widely used. So a lot of time we also discuss about the convolutional neural network. For example, image segmentation, image, then also object detection. Okay, so we also discuss a lot of time this type of model. And this is also very important. It's called the recurrent layer. Okay, recurrent layer. So recurrent layer is used to neural network to handle the sequential data by maintaining information across the time steps, making it suitable for tasks involving context and also order. As well as you can see, it designed for sequential data like time series and text, use feedback connection, maintains an internal state across the time step, capture the temporal dependency in the data, commonly used in the NLP and also speech processing. We also use this recurrent layers. And dropout is the use to regulation technique to reduce the overfitting and randomly detective sub-neurons and encouraging the network to learn model robust feature. Helps to prevent overfitting. Overfitting is one kind of problem. Okay, helps prevent to overfitting. Randomly drops neurons and during the training, each neuron is the kept with a probability. Reduce the dependency on the specific neuron and improve the generalization of the model. Then pooling layer, it's a two type, max pooling and average pooling. So if you check this is the max pooling, okay, it's average pooling. So it's a 2 into 2 pooling straight 2. Suppose this is the, so here we find out the maximum value. See, you can see maximum value is the 12. So it's create the 1. Here we find out the maximum value is the 7. So it's for the 7. So here we find out that maximum value is 13. So take the 13. Here we find out the maximum value is the 14. So take the 14 and create the max pooling. So it's called the max pooling. And also get the average pooling, just simply calculate the average between this. Okay, 2 into 2, 2 into 2, you can see 2 row, 2 column. It's called the 2 into 2 pooling. Okay, so we find out the maximum value from here as well as the also average value. Okay, so max pooling and average pooling. So it helps you to reduce the size of feature map, decrease the computation cost, help prevent overfitting. Common types including max pooling and average pooling, widely used in the CNN. For image processing tasks, we also use the max pooling and also average pooling. And finally, best normalization layer. So best normalization layer, normalize the output of the previous layer using the best mean and standard deviation. Best mean and standard deviation just use. And helping improving training stability and speed. Okay, for the best normalization, it also help you. So this type of hidden layer we also apply in our hidden layer section. Okay. So there's a lot of theoretical topic. So I will send you this PDF file as well. Also send you some reference book. So you also try to read all of those. Okay. Then we just also show you some practical example further class. Okay. How to apply hidden layer or also others also apply. Okay.
Okay.
And in this time, first of all, we try to cover this type of topic, then jump, okay, for others because it takes some time because it's a more theoretical part. So further, we first time we deep learning this type of we try to cover, okay, computer vision or PyTorch or deep learning, okay, then move to the others, no problem, okay.
Okay. And Major, like next week on Friday or Saturday also, because that high resolution. Even in DEM also it is possible, like in DEM allows data is for 12 meter, right?
Okay, so for this class, basically Friday is not possible. Friday I have also 2 class and also night I have also another class for 7 days. Saturday is better for me. And if you want, you can also join the morning, suppose if possible from your side. If you want, you can also join 8 a.m. or 7 a.m. from your Saudi Arabia time. It's also possible for me. There is no problem.
Okay, or next week Saturday we can consider that class and we can just see that, because I just want to do my that in 7 days classes.
I will try to discuss about that.
NDVI, land use, everything I just wanted to do in that 2.5 meter resolution. I want to see how accurate it is.
Okay, we also try to discuss about that, how to work.
Yeah, that we'll do next week. So that will be easy. Then we can continue. So just one question, like satellite imagery can be taken into 2.5 meter. That I know. What about the DEM? Do you have any? DEM we have allows 12 meter. Can we make it more high resolution to that?
Okay, let me check some tutorial. Let me check some reference paper about that. Then I will inform.
Okay, please.
No problem.
Please for satellite and DEM, please. Huh?
Okay,
thank you.
Okay, thank you.
Thank you so much. Thank you so much.
Thank you. Have a good day. Bye.